Hello, good morning, sir. The topic for our assignment is Twitter graph dataset analysis. We are a team of three members: Aditya Tiwari, Nimish Mangi, and Prithviraj Kamble. So, the algorithm that we have chosen is the PageRank algorithm from the Sparks graphics library. The PageRank is the algorithm which is the foundation of Google search and developed by Larry Page in the foundation days of Google only. So PageRank works by counting the number and quality of links to a page. What does that mean? Google, we all know that ranks hits web pages. But how does it rank? It uses this PageRank algorithm. The more important the theory is the more important websites are likely to receive more links from other websites. Means they would have more inward links, more links connecting from other third websites. That is the theory behind PageRank. Let's understand the mathematics. Here I have taken a simple example of 4 nodes A, B, C and D. I will try to calculate the page rank. The formula for calculating the page rank of a node U or a vertex U is given by sum of page ranks of all the web pages which have an inward edge to A. Let's take an example. A has 3 inward edges from B, C and D. So the page rank of A will be the sum of page rank of B plus page rank of C plus page rank of D. And here we have also divided the respective page ranks by normalizing it. Means page rank of B is divided by L of B. What is L of B? L of B is the number of outward links from page B, so that it gets normalized. Similarly for page rank C and page rank D. Okay, and page rank of B is page rank of D by L of D. Why? Because B has just one inward edge from D. And L of D will be 3 because D has 3 outward edges. Page rank of D is 0. Why? Because D has no inward links to it. Means page rank of D is D is the least important out of all the 4 pages here. Now you must understand this is an iterative algorithm because this algorithm initializes the ranks of all the pages to, let's say, 1, or we can 1 by n. We can initialize the ranks of the page. Later, iteratively updating, this algorithm finds the page rank until the algorithm converges. The page with the higher rank is shown above than all other pages with low page rank. Okay, the formula for calculating the page rank, here is a slight updation. Here this D, a factor D is introduced. So this is a damping factor, usually lies between 0 to 1, but we take it as 0.85. What is damping factor? So damping factor is the probability, it describes the probability that a user who is surfing the internet is likely to go on a random page rather than from a page which he is currently on to the links which is connecting from that page. Okay, so the probability that he will go on some random page is given by D. So the formula for page rank is updated like this. Here T1 to Tn are the pages which are having inward links to A. We are calculating the page rank of A, and the C of T1 is defined as the links going out of page T1, T2, Tn. Okay. So next I will have my friend Prithvi who will discuss the data set.
So, hello sir, this is a Twitter dataset that we have taken from Stanford Snap, and some details of this dataset are as follows. So, in this dataset, we have edges which represent the connections between the nodes. Here the nodes represent the users, and the connections are of 3 types of followers: the mention and the retweet network. So, Twitter dataset on the hidden topics. Nodes represent users. Edges represent user actions like retweet. Directed edges are formed when users perform action with respect to each other. This dataset likely has intricate patterns, making it a rich subject for investigation. So next part to handle Adit.
Hello, I am Aditya Tiwari and I will be explaining the Spark installation on Ubuntu 22.04 version. First, we execute the sudo apt update command and update the Ubuntu operating system. Next, we install Java, Git and star. In the third step, we download and extract Spark. In step 4, we configure the required environment variables for Apache Spark so it is easy to execute Spark commands in any directory in the Ubuntu operating system. In step 5, we update the .profile directory in order to make sure that the changes in environment variables have taken effect. Experiment 1 will be taken by Nimish.
Hello sir, for the experiment 1, now this is the most basic experiment that we can perform this page rank algorithm. So I explained that we are having the Twitter dataset. Now the dataset is comprised of 3 networks. The follow network, which if a person A is following another person B, there will be a directed edge from A to B in that follow network. The retweet network, similarly if person A retweets another person B, it is the retweet network. There is a directed edge from A to B, and similar goes for the mention network, that if a person mentions another person B. So what I did is I combined the networks. Which 2 networks? The retweet network and the mention network, and ran the page rank algorithm on the nodes. So there will be a graph will be created. Hope you understand. There will be adjacency list if I combine the networks using Spark only, and then I ran the page rank algorithm on the graph which is created. Running that graph, we will be able to find the node having which is the most influential, or the node which is having the highest page rank. When the algorithm converges, we will have the result. So let me show you the result. So here you can see when the Spark session terminates, the most influential person is user ID this with page rank of this. The next experiment which I did is a bit interesting. Here what I did is like we all know that in this social era, most people are being fake influencers which are gathering followers using money. So what I did is I use a simple concept that if a person A is to follow another person B, he is likely to mention the person B somewhere or retweet his post if he is interested in the particular person. So what I did is I calculate the threshold probability or a percentage that if this is the percentage of followers who are referring their person, the persons who follow one person, if those persons are referring that person A which is being followed somewhere in their tweets or their comments, that means they are real followers. Okay, so how I counted those real followers or the probability? I found the common edges between the follows graph and either retweet or mention graph using intersection. Let me explain this. I took the intersection, I took the union of retweet and mention graph. Okay, and then the intersection with the follow graph. Doing so will give me the number of people who are following the person B and also mentioning or retweeting them somewhere. That's what I did. Now I divided this number by the total number of follow edges that I have. Total number of persons who are actually following. This will give me the probability. Because I have a big data set, I can take this probability value to be real. Means if this percentage of users are following, if this percentage of followers of a person are actually mentioning or retweeting him somewhere, then it is real. So what I did, let me show you with the example. Here you can see the probability, that threshold probability I got is 0.018, which is approximately 2% we can take. So here I found the top 10 influencers using my first experiment only, and for those 10 influencers, I have their followers. Now I check how many of their followers are actually retweeting or mentioning them somewhere. So this is the percentages that I got. So you see the user 108150 has having 75% of his followers mentioning or retweeting. Maybe he is another Salman Khan, but yeah. So these followers are like, the number is very less, 0.06, 1.5. Or here we can say like 1.66. This is very less. If it is like equivalent to 2%, we can say the person is having real followers. Else there are some or the other followers which are earned through money. Okay. My friend Tiwari will continue.
I'm Aditya Tiwari and I'll be taking up experiment 3, which performs an in-depth impact analysis on the Twitter retweet graph dataset. This analysis makes use of both the PageRank and the connected component algorithms and merges their output in order to gain additional and interesting insights into both the influential users in the dataset and also the clustering properties of the dataset. In the first step, we determine the PageRank of all nodes in the graph dataset. In the second step, we identify the clusters using the connected component algorithm. In the third step, we combine the outputs of both the PageRank, and the connected component algorithms in order to get a list of tuples which have the following form: node ID, PageRank, and component ID. That is a list of all nodes along with their particular PageRank and component ID. Now we group this list of tuples by PageRank and component ID in order to get the number of nodes having a particular PageRank and component ID. In the fifth step, we get the top 10 components having the most number of influential users, that is, users having a high PageRank. This analysis informs us that which components are or which clusters in the graph dataset are highly influential or are a hub for highly influential users. I will now show the report. Here we can see on our right the output for experiment 3. As we can see here, at the top we have PageRank score approximately 1, connected component ID 2, having node count of around 223,000 nodes, which is exceptionally high compared to the node count of other PageRank and connected component combinations. This tells us that the connected component having the ID 2 is a huge hub for highly influential users. We can now target this connected component or cluster and analyze it further to uncover interesting insights. This kind of analysis is extremely important for several stakeholders like advertisers, for example.
So now we can explain pros and cons. First of all, I explaining pros. So explore graph, dataset and algorithms. Carried out impact analysis and other experiments. Used Apache Spark's graphics libraries. So second is cons. So no topic specific analysis, no comparison with existing research on the dataset of algorithms.
Hello, I am Aditya Tiwari, and I will now start the Spark setup and code execution demo for the DSS assignment video. I would first like to start with the install spark.sh shell script used to install Spark and other software necessary for executing Spark. Scala programs on Ubuntu 22.04. Here we can see the various commands executed by the shell script. We have sudo apt update used to update the apt repositories for Ubuntu. Next, we install the default, the latest stable version of Java development kit, Scala, Git. Then we download the tar file for Apache Spark 3.4.1 binary Hadoop version 3. We then extract it and move it into the default directory of /home/aditya. Next, we write the following lines in the .profile file in order to set the necessary environment variables in order to execute Apache Spark commands anywhere in the Ubuntu system, irrespective of the directory where Spark resides. In the end, we source the .profile file in order to make sure that the changes in environment variables take effect. I will also show the same lines written to the .profile file in order to set the required environment variables for Apache Spark. I will now start with the code for experiment 1, the file for which is named influential retweet mention.scala. I will first start by explaining the code and then execute it. We first import the graphics library and load the retweet and mention datasets in the retweet graph and mention graph variables respectively. We then combine the two graphs by merging their vertices and edges, and then run PageRank on the combined dataset. We then find the user with the highest PageRank score, which is also supposed to be the most influential user in the combined network. We then print the details of this most influential person. That is the ID and the PageRank. Now let's execute. I'll use the Spark shell in order to execute the script. I'm sorry, I have to change into the project directory first. First the Spark directory and then the project directory. Sorry, the Spark directory. Named Twitter graph analysis, where on the left we can see all the files inside the project directory. I will now execute the code for experiment 1. The code has executed successfully, and the most influential person is user 185012 with PageRank of approximately 0.999. So we now have the ID of the user who is the most influential in the combined network of mention and retweet graphs. I will now move on to the code for experiment 2. The file for experiment 2 is named probability retweet follow mention.scala. I'll explain the code first. As before, we import the graphics library. We then load the graph datasets for retweet, mention, and social graphs. We then count the number of edges in the social graph or the followers graph. After that, we find the common edges between the followers or social graph and either the retweet or the mention graphs. That is, we find the common edges of the followers graph with the retweet graph and the common edges of the followers graph with the mention graph, and store it in these two common edges with retweet and common edges with mention variables respectively. Next, we count the number of common edges and calculate the probability of followers either retweeting or mentioning the people that they follow. We finally print these probabilities. SC dot stops the Spark context. Let me execute the code now. The execution for the code for experiment 2 is in progress. The execution for experiment 2 code has completed, and we can now see that the probability that a follower retweets or mentions the person that he or she follows is approximately 0.0185. So we have the probability to be around 1.8%, which seems to be somewhat low and gives us an insight on follower behavior in the Twitter network. We will now move on to experiment 3. The code file for experiment 3 is named impactanalysis.scar. I'll explain the code first. As usual, we import the graphics library and create a graphics graph by loading the retweet network dataset. We then calculate the page rank for all the nodes in the graph. And after that, we calculate the connected component ID for all the connected components in the retweet graph. We then take the step of combining the PageRank scores and the connected component IDs and finally get tuples in the form of node ID, PageRank score, and connected component ID. We have this list of tuples, which we then group by PageRank score and connected component ID in the next step. We therefore get the number of nodes having a certain PageRank score and are in a certain connected component. After that, we find the top 10 connected component IDs having the highest number of influential nodes, that is, nodes having a high page rank. We then print these top 10 connected component IDs along with their node counts. After that, we stop Spark context. I will now run the code for experiment 3. The execution for the code for experiment 3 has completed, and we have the results printed out. We can see that the topmost PageRank scores are all approximately 1. And we have connected component ID 2 with a node count of 223,000 approximately, or 223,833 to be exact, which is much larger than the node counts of the following component IDs, which tells us that the component with ID 2 is a huge hub for highly influential nodes or users. The importance of this experiment is in the fact that it allows us to identify not only the number of influential users, but also the component IDs or clusters which are high in number of influential users or are highly influential. With this, the demonstration comes to an end. Thank you.